Okay, another triangle problem. Here we're given all three sides. So we know little a, little b, and little c. And so that means we have to use law of cosines. Unless you recognize a Pythagorean triple, of course, but this is not a Pythagorean triple. So law of cosines looks like this. And really the A, B, and C you can kind of move around as needed. And that should be a cosine, not a sine, because it is law of cosine. So you're copying along with me. Cosine. Cosine. So a squared equals b squared plus c squared minus 2bc cosine of a. We're going to use this to find our angles in this case. We're going to use this formula to find our first two angles, and then once we have those, we can subtract from 180 to find our third angle. So I'm going to use this to find angle A and angle B. So here we go. Sorry, my smart board is having trouble waking up this morning. So A is 9. 9 squared equals 7 squared plus 5 squared minus 2 times 5 times 7 times cosine of A. And I like to move things over kind of in groups. I like to move things in 3 steps, I guess. The first thing I move is this. So we're doing backwards order of operations, which sometimes is a little tricky to think through. Here that means we're going to subtract our 7 squared and 5 squared. You can get the decimal approximations from the beginning, but this is more exact, especially when you're working with angles. I think that's good to be more exact. Okay, so that cancels over here. So what do I still have left on the right-hand side? I have negative 2 times 5 times 7 times cosine of A. The other reason I like doing this in steps like this is that your calculator can handle what we're doing here. So we're going to have kind of a mess, but because you can do that nice stacking fraction, your calculator can handle that mess really easily, and it allows you to be more precise. So since you have technology that can work for you, you might as well use it and have less rounding error and really less places to make mistakes by, dropping a digit somewhere or something, anything else funny that can happen. So I have 9 squared minus 7 squared plus 5 squared in parentheses over negative 2 times 5 times 7. The other side is cosine of A. And the way that we move that cosine is to take the inverse. So I'm going to do cosine of -1. And that cancels those cosines. I would put that into your calculator exactly the way it looks. So use that stacking fraction, that pretty fraction button available to you in your calculator if you're using TI-84. That's alpha 1 equals, enter, we'll get that for you. If you're using Inspire, you can get to it a little easier, I think, through your little menu book guy. When you put this in your calculator, you should get 95.74 degrees. And if you don't, and you're watching this video in class, pause the video, come up and see me, and I will help you get that solution for A. Okay, to find angle B, we're going to do the same steps. We're just going to have this original equation is going to be in a little different order. So if you want to look at this, if we're going to have a B here, then we need to change our A's, our B's on the other side here to A's. And that's going to be a B. So B B is 7. So to find angle B, we're going to do 7 squared equals 9 squared plus 5 squared minus 2 times 9 times 5 cosine of B this time. So last time if the algebra was a little too much for you, this time you try it. Go ahead and pause the video, see if you can get B all by itself and put it into your calculator. Okay, hopefully you got those pieces moved over. The first thing I'm going to do is subtract 9 squared plus 5 squared to this other side. You can use those parentheses or you can do minus 9 minus 5 squared. Make sure you don't drop the negative in front of the 2. The reason the ACT likes this, I think, is because triangles are important, but also for the precision piece. Like you have to be a pretty precise mathematician to get this done. And then we're going to take the cosine and the inverse cosine, arc cosine, maybe you've heard it called either of those, both sides. Again, I really encourage you to enter that into your calculator just the way it looks. Don't try to make it a decimal in there or simplify that at all. That's too much work. Go with the way it looks. When you put that in your calculator, you should get 50.70. And if you don't, again, I'm here to help. So if you're watching this outside of school, for the star by, put a Post-it on it and come and see me for a couple minutes before school or during class. If you're trying this one during class and you didn't get 50.70, pause it and come show me your calculator entry. All right, last step. 180 minus our other angles is going to give us angle C. So angle A was 95.74. Angle B is 50.70. And that makes angle C 33.56. And if we look back at our diagram, our smallest side should be across from our smallest angle. And our biggest side should be across from our biggest angle. A was our biggest angle and C was our smallest. So it's a good kind of reasonableness check for